Hi, so we're going to talk about the ellipse today. We'll probably spend 2 days on it, and I'm going to go straight to the formula and introduce you to doing some problems. So here's my high-level summary. Sorry about the pink marks. I was playing with my online tools, so I can't erase this, so we're just going to go with it. Okay, so let me make this a little bigger. Okay. So on the left side is a horizontal major axis ellipse, which is laying kind of flat on the ground, if you will. It's like a football laying on the ground. And the long axis is on the horizontal. This is a major axis. The longer side is horizontal. And the shorter side, what they call the minor axis, is vertical. Versus the ellipse that has a vertical major axis, has long side vertical axis, and the short side, the minor axis, is horizontal. So let's first look at the ellipse with the horizontal major axis. So some terminology first. As you might have seen in the Khan Academy video, the ellipse is defined as all points such that the distance between F1, the first focus, and the point, plus the distance between the focus 2 and the point are the same. Okay, so if you're curious, you can go back and read the book about that, or there are other videos available that explains the definition of an ellipse. But we're going to go straight to the equation of an ellipse. Okay, so some terminology we should define. First, we start out with two foci, okay, F1, F2, focus 1, focus 2. The center of the ellipse is the midpoint between F1 and F2. So here's my center, and that is defined as H and K in this case. Okay, two other points that are important is a vertex, V1, V2, two vertices. Okay, and that is they lay on the horizontal major axis, or the major axis. The vertices, V1, V2, focus, and the center are all on the same axis. Okay, and that's true for the vertical axis as well. Okay, these 2 points here are called covertexes, covertex 1, covertex 2. That doesn't come into play yet, so we're going to, you can write those in if you want to. But what's important here is this ABC. These distances are defined as distance A is the distance between the center and the vertex. It could be either one, they're the same on either side. So that's A here. B is the distance between the center and the covertex. So this distance is B, and also this distance is B. C is the distance between the center and a focus. Either this one or that one, they're the same. So A, B, C. Okay. What we know is that because A is this distance between center and the vertex, that A has to be larger than B and also larger than C, just because of the definition of where the vertex is. And so A is greater. In this case, A is the largest of the three. And the ABC, the three numbers have a relationship, kind of a Pythagorean relationship, that is A squared is equal to B squared plus C squared.